All right, I'll get going. So yeah, today we're going to go over the Windows internals, mostly just a high-level overview. We're only going to get in the nitty-gritty for a couple of things. The main reason is covering Windows internals in its entirety would take about 3 to 4 meetings. And I actually had to cut this down because my first draft of this would have taken about 2 hours to go through. So hopefully this will fit within time. If not, I'll just stop when we get to the end. But even just for like the basic Windows host and security model, there really is a lot going on that isn't there in Linux. So this is the meeting flag for today. Should be up. Slides are up. If any of that doesn't work, just go yell at me and I'll go fix it. But yeah, the joke here is a lot of the modern Windows kernel really came around with Windows NT. And I'll get like deep into the kernel internals probably near December. But almost all of that infrastructure is a holdover from what happened with Windows NT. So that is very much, if you look at your Windows 11, that is still the beating heart of the operating system, is this flaming pile of garbage. So yeah, so as you can see, there is a lot to go over just to like go through the basics, right, compared to Linux. So I'm going to go over like the Windows security model and just how they think of things, how the OS is intended to function, how they model things, which is a lot, right? They have security identifiers for objects, and then those objects create logon sessions. Those logon sessions will have tokens, and those tokens will have privileges, right? So it's like this very big, complicated nested model. And then I'll just hit on some brief, like one-off things, the difference between administrator and system, which is kind of confusing because there's no analog for Linux. The difference between ACE, a DACL, and then the stdl language, a little bit on the actual Windows threat model, and then how shells work. And finally, I'll go over the NTLM authentication protocol, because it's very different to anything that exists in Linux or other like software. So before I get into this, where's Michael? Is Michael here? Yeah, okay. Do you just want to talk briefly about what's going on with Cyberforce for the second team?
Team 2, this is kind of blindsided. Got put on. Yeah, so that's not something that we had originally planned on happening. I was talking to the other guys about it yesterday. We think that the best course of action is, as we continue to do like Cyberforce training, Team 2 should just attend anything. And let's plan for the idea that they could just accept you and then during the competition in the next few weeks. So although we got our materials in on time, and it did take until the final week for us to even get approved to bring in a second team, there are a million questions we could ask about why this happened, but ultimately there were 100 spaces for teams that filled up. Now we do have Team 1 still going, but that doesn't mean that we don't want Team 2 ready to go. So
yeah, I think according to what they said, it's the highest number of signups they've ever had. So I think they're just out of space.
Yeah, in the meantime, here's how we can make up for that. So some of you are probably thinking, like, okay, now what? What happens if I ultimately don't go to Cyberforce? Well, then we need to step up the TCP restrictions. So we got us at any point where you have questions about this. I posted an announcement so you can find them. So yeah, and come find me after the meeting. We have lots to get this done.
Yeah. Okay. Cool. So I do also want to put out a bit of a disclaimer. I tried to get more practical stuff up in the cyber range. I didn't have time to deploy new boxes for this. It's very complicated. So today is unfortunately going to mostly be me talking. I'll try to get stuff up by next week if I can find the time. But yeah, deploying some of this stuff, as I think you'll quickly see, is kind of terrible. And it takes a lot of time to go get that together. So hopefully you guys can bear with me. Thankfully, once you understand the theory, the practice is pretty simple, especially if you understand what's going on for the Linux side of things. So most of this is just going to be conceptually figuring out how do I adapt the same family of vulnerability to a new exploit, right, on Windows. Okay, So yeah, Henry, I don't know if you had something you wanted to bring up for this since this was sort of your approach, right? But for Linux, just to recap the security model, it's pretty simple, right? You have users, you have groups, users have IDs, groups have IDs, right? You have a fixed number of bits that say what can you do to a given thing, and then you can use sudo to run as other users, right? So a lot of times for Linux, our security is going to be applied to like objects, and it's almost always like files in terms of how the access control is divvied up, right? So outside of a couple edge cases like SUID, SGID, and like file attributes, this is a pretty concise model, right, of how it works. It's perhaps too coarse-grained, right? We have to kind of hack around it to get granular permissions, but this is a pretty simple security model. Windows is much less simple, right? You have these large like families of different functions, and they'll all kind of interoperate and relate to one another. So it's a very large, complex system. Now, as attackers, that's good because the more complicated your system is, the more likely it is to have bugs, especially logic bugs that are pretty crippling. But it also means you need to invest a lot of effort on the front end of just understanding what the system is and how it works. So in Windows, you're going to have security principles, and these are like things, like they're like your nouns, right? So that'd be a user account, a group, a computer, a domain. Like, it'd be like a noun related to authentication is what your SIDs are going to relate to. It's an SID that says, hey, this is how I identify a security principle. And for Linux, right, we're doing a lot of our access control on files. In Windows, there is some of that. There's also doing your access control on security principles. So that's like the main difference in how it's modeled. So this is how you break down reading this monstrosity. S1 is just like your version tag for like, yep, this is an SID. 5 is the identifier authority, which is the main thing that can issue SIDs for it. So like for your local system, that's usually going to be a 5 for entity authority system. That can change in Active Directory, but you don't have to worry about that for now. Sub-authorities, this is like the actual like meat of what's here. This is like, what does this thing belong to, right? So if you have multiple different domains, including parent and child domains, this is how you identify what this SID lives in, right? So like for the UIUC Active Directory, a lot of that sub-authority string would be to identify that security principle as a member of the UIUC Active Directory. And then lastly, on the very end in yellow is the relative identifier. That's like the actual ID. So our ID 1000 is like your default user that when you go open up and do a new Windows install or like, hey, add my default user, that's gonna be your RID 1000. So that'd be like your user ID. And then on your physical Windows computer, the thing that manages all of the SIDs is LSAS. It's run by Local Security Authority. I think it's Local Security Authority Subsystem. I don't remember exactly what it stands for, but that is the thing that is handling these. There's no like one Etsy Shadow type equivalent on Linux. It's dynamic as a process. So there are some common SID patterns that are worth kind of committing to memory if you see them, because when you're reading DACLs, right, which is, I'll get to that later, like what's covering your access control, you're gonna start seeing patterns and being able to immediately spot, hey, that looks out of place is gonna be helpful because there's gonna be a lot of information going through this. So a very important one is just the everyone group, because you have something that has like excessive permissions, right, and it's tied to the everyone group. Well, that's like the equivalent of, mode 777 on Linux. It's like world writable, anyone can mess with it. Local admin is very common. Usually that's the S1521, whatever in the middle, ending in 500. S157 is anonymous, which is a big deal if somebody has the ability to log into something. Let's say you have an SMB share that is readable by the anonymous SID. That means absolutely anyone can go read the contents on that share, right? So there's like no confidentiality. Local system is similar to local administrator. It's like your Windows equivalent of root. 501 is your guest account. It's disabled by default. It shouldn't really be used in this day and age. It's very similar to anonymous. 502 is Kirby TGT, which is an Active Directory thing that's very, very important, and I'll cover the specifics of that later. And then in continuing the Active Directory trend, right, you have your domain SIDs, and these are for the groups, right? Because an SID can point to a bunch of different types of things. So you can see, even though 500 is local administrator, 512 is domain administrator, 513 is domain users, right? So these are like group families almost. Okay. So cool. Now you have an SID, and you can be like, this points to a user or group, right? So how do we actually translate that into getting access at runtime and doing those access control checks? When a user logs in, the LSA, which is what runs all your SIDs, will give you a logon session. So your SID is like your permanent ID. Your LUID is like your logon session. So you log in as your user with your SID, like, cool, I have an LUID. This is what regulates my access for the duration that I'm logged in. And then every time you create a process, right, you run something on your computer under that LUID, it'll have a token. And the point of this, that's different from Linux, right, which is in Linux, kind of like I'm root or I'm not. You have capabilities, but it doesn't really matter. This is so every process you run could have granular privileges. So your general user can have like a bunch of different powers, but you can run processes that only have a subset of those. And that's very, very important because that's the equivalent of like not running with sudo on all the time on Linux. If that makes sense. The whole point of having this logon ID and a bunch of different tokens is that if I have some random thing I'm running, like let's say a Steam game, it does not need to inherit every single possible token permission from my logon ID, right? So that's generally the idea. Is each process gets its own set of permissions, and that's what's regulated by the token.
You're telling me that not every process I run get SE debug?
Yeah, so I'll go into that later, specifically why some of these privileges are dangerous. But every privilege is like getting to skip an if statement in your kernel, which can be very, very scary. So yeah, the other thing is in terms of them like propagating, right? You'll log in, you'll get Explorer as your process, which is like your desktop. It's like what you see. And then every time you create a child process, unless you're explicitly doing something to request a different token, it'll do a copy by value and just inherit from the parent. And that's how access control is run. Ray, what's up?
They're gonna have a pop-up that says like, do you want to run this with that?
You're getting ahead. Hold on. That is an entirely different mechanism. So yeah, it's already a lot. Yeah, in fact, that might be a great segue. Yes, it is. Awesome. Okay, so that governs your process integrity level. Now, integrity levels, even though they're their own thing, the best way to think of it is how much of this subset do you inherit? So the default, when you're not clicking that box, is medium. Medium is like, the bare minimum you're going to kind of need to go run normally. And what's lower than the bare minimum? Well, basically not touching your OS at all. And that's what a browser will have to make browser RC really hard, right? So when you're running your normal applications and you're logged in and you're not ticking that box, run medium. And it's like, all right, cool, but I want to use all of my privileges, right? And run it. So if you're in the local administrator group, which is when you open up your Windows computer and you make your first user, you're in that by default. So any workstation, you're in that. It's kind of like in Linux when you're running and you have the ability to use sudo, but you're not using it. Except in this case, you have user account control, which says, I would like to go create a new process with high integrity, right? And that's that box tick is. And then when you do that, it'll go through some special token magic and spit out a high integrity process. And what's cool about the high integrity processes is that they can inherit more privileges from what your logon session can assign. So if you're administrator, you can have pretty much any of them. And if you're in medium, you're gonna have like 4 or 5. But if you're a high integrity process, you could have all of them, right? If you needed it. So the idea is kind of like sudo. This is so administrator is not running everything, fully privileged all the time. But what's really cool about this is that skipping that box pop-up and creating a high integrity process from a medium integrity process is not considered a vulnerability. And it has not been patched, ever. Which is really interesting. Because imagine if you were on a Linux box, right? And you had sudo access and required a password, you know the password. Well, as an attacker, you're kind of screwed, right? Because I can't go run sudo if it requires a password and a password. But for Windows, it's not really the same because you could just jump around it and that's considered completely fine, which is a very, very scary thought. So yeah, again, the thing that's doing that regulation of, I'm doing that check, which is usually the box in the GUI. Sometimes they'll ask for a full login, is user account control. So when you see it goes like, ba-da-dum, and there's the shield, it's like, would you like to do this? Yes or no? That's user account control. And it's this weird sort of situation where skipping all of that is a feature. It's also flagged by antivirus. because there's some competing models of what's going on. But this has been a thing since like UAC was introduced, so early 2000s. So what's weird about this, again, is you obfuscate it and then skip that and you escalate your privileges that way. That's working as intended under the Windows security model, which is strange, right? That's not how we run things in Linux. You can kind of hop up a rung, and that's considered okay. So what's interesting about this, I mentioned this a little bit before, but every time you have a workstation, you install Windows on it, and you add a new user, that user is in the local administrators group, right? So that means they have the ability to get that fully privileged like logon session. So what's really interesting is if you can get a UAC bypass working, just one of them, right? And you can just snipe some already existing, like technique off the GitHub and just change it. That means on every default configuration Windows computer, you can now escalate your privileges and you just win, right? So that's not the case for servers, right? Because they're usually more locked down. But for like this computer right here, if you had a UAC bypass, you could hop from medium to high integrity, right? And that would work on pretty much anything. Okay, so we can get more privilege than that. So when you hop in high integrity admin, you can have a lot of powers. You don't have all of the power, right? And as hackers, we want all of the power. So Windows has the system account. So system is like root and is both more and less privileged than administrators. What do I mean by more privileged? Well, you get to access other things running a system, right? So if you want to get into that security authority and access that, you need to be the system account to do that. But you're less privileged because you don't get to do human things as a system account. You can't log in and create a desktop, right? Or do anything that would require a GUI. You can't use an HTTP proxy by default as system, right? So if you're in an organization that has a web proxy and you're trying to control that computer over, let's say, HTTPS, right? And then you go run something in a system, well, you won't be able to call out because only humans are supposed to use the web proxy. So system is strange. But if you want to get all of the privileges over a Windows computer, you need to get system. And before I get into this, what's really, really funny, and I'll expand on this later, is that, how I said hopping from medium integrity to high integrity is not a security problem? Well, hopping from admin to system is also not a security problem. And under the formal Windows definition, hopping from user to system is a security problem. But, if you know like basic transitivity, right? Well, hold on, we can go from user to admin to system and using only features. And that's okay, but it's not okay. So like there's a number of these, which is why having a complex system like Windows is really hard to secure because they can't even get it straight in terms of what you're supposed to be allowed to do. Okay, so in terms of things that are even harder to configure properly, you know how in Linux, when you ls a file, you have those 9 bits of RWX, 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 and you can go manipulate your access control? So Windows said, yeah, we could do that same thing, except we can make it 25 times larger. So that is the security descriptor definition language. So this is your Windows equivalent of those 9 bits, and we set this on things. So that'd be like files, or we can set it on registry keys, or we can set it on who can talk to the drivers and set ioctls to them. Just a
comment. Like registry keys are also kind of a file system.
Yes.
It is just really cursed and is clumped into like 3 mega files. They're 100 megabytes each or something. And there are more of them, right? Like each one of them have multiple backups. You'll learn more about this in CCD and stuff, but overall, it's just a very cursed way of managing the config files. Yeah, registry in themselves is very complicated. I didn't want to get into it, but it's like a giant dictionary on disk that stores a bunch of configuration settings. And there's a lot of really fun compatibility features. Like, let's say the compatibility library they need to run every time the user logs in as administrator, right? So there's a lot of really cool things you can abuse in registry, but I'm not going to cover that here. So this is how SDDLs look. And this is the simplest of the SDDLs. This is like the equivalent of Chmod 777 on Linux, where it says, hey, S110, which who remembers what S110 is? Pop quiz. Anyone? Everyone. Yes, that's correct. So I'll break this down in a second. This says, hey, everyone is to do all of the things on the object that has this SDDL applied to it. And you can view these in your terminal. You open up a PowerShell window and do get-acl, and then on the thing, and that'll spit you out one of these. So you'll have your owner, which is BA, built-in administrators. You can also do it by SID. It just gets really, really wide. Same thing for group.
And then you have the DACL, which is your discretionary access control list. Right, so this is like default access allowed. We're not worrying about object GUIDs. We have all these privileges, and we're doing it for the S110 SID. So I made this as obnoxious as possible in terms of the colors to really, hammer in how many of these things there are. But a lot of it's pretty intuitive, like read property, write, right? Can you read or write to the thing? Create child and delete child is interesting because that means different things depending on the object. So if I have a directory with create child and delete child set, well, that's pretty easy. I can create and delete things like in that directory. If you apply that to a file, I don't think it means anything, which is just a weird way of setting it up, right? Like list children is like your ability to go like list the contents of a directory. If it were a directory, it's a file, doesn't make any sense. If it's a registry key, I think it'll let you look through like subkeys, right? So the main things we're really interested in, other than the read and write property, is if you look at the bottom three, these are meta level settings of who can write the DACL, who can change that string. What's up, Suchit?
Assigning like generic all, why do you have the other stuff? Is this just like an example, or like why would you assign that all of this?
This is, I believe, just how it's handled. Like if you were to go create a file like this that's everyone readable and just tick all the boxes, right? I have seen examples where you would have generic all and write DACL and everything, but that's complicated because that would be an active directory. So an example would be if you had a domain administrator, they would have generic all and write DACL over the domain itself, where they can go do anything, and they also have the ability to go right to the access control list, but generic all encompasses everything. So it is redundant. I don't know why it's spelled out like that, but you will see cases for real where you'll have multiple permissions that do the same thing.
I mean, if anyone wants to just check them out for themselves, obviously you don't have to actually convert anything to SDDL. You can just simply right-click on a folder or a file, right, and then go to properties and then see that list. Or there are more simplified views of that, and then you can check it out for yourself. But by default, it might set to something like some things might overlap, etc. Yeah. The other time you'll be reading SDDLs a lot is later on. I'll show you guys a tool called Bloodhound, and that maps out access among human identities of like who can control what accounts. That's the other time you'll be looking at this a lot. But yeah, this is a general idea, and it gets a little more complicated. But the whole idea, right, is if we look at Linux and we have this vulnerability of what happens if we have a privileged thing that's running and we can write to it and we shouldn't. Well, usually you can take it over or cause some damage. And even though SDDLs are this like big, scary, construction of how to do that, the exact same vulnerability exists there if it's misconfigured. It's just a different exploit, a different technique to go take advantage of it. So here are some fun abuse cases, and it looks like my text got really squashed here. But you can have excessive permissions, like I went over in the Linux privilege escalation meeting, where this applies on things, right? So what happens if I can send commands to privileged drivers running in the kernel from the everyone group? This is actually very, very common, especially when it shouldn't be. This is a very easy way to go escalate privileges, just all the way to taking over the kernel. And that's an example of a weak SDDL. Because people aren't necessarily locking down like the pipes and stuff that drivers are talking through, or the ioctls to go send that to them. An obvious one that's kind of similar to Linux is writing to a file you shouldn't be able to write to, right? Or writing to a file that someone else is running. That's an obvious abuse case, Another one is having write DACL where you shouldn't. So this is very common in Active Directory misconfigurations, where you'll have the ability to go change the ACLs of like someone else's accounts. Like, why do I have this, right? If you do that, you can just directly take over the account. Like you just say, hey, I'm going to give myself generic all over you by writing to the DACL, and then you control the account. And the other thing is, right, that's where we have too many permissions. What if we have too few? Like, because this is such a granular security system, I can go create a service, right? And let's call it Ronan's rootkit. And then I can remove the ability for anyone else to list it on the entire computer. You go list your services, it's not there. And because the way SDDL works, to go hunt for this, you have to know the name of the service to go reset its SDDL using your generic all, and then list it, right? So what if I just name my rootkit 64 characters of random garbage and set it, right? Well, you're just never gonna be able to see it again. So there's a lot of things you can do to mess with the system by being overly restrictive in your permissions, right? It's not just having too many of them. You can have too few and create these really weird edge cases, right? That like antivirus and EDRs know what to do with. Wait, I just have a thought. Can you create like an like a directory that cannot be listed but exists?
I believe so, because if we go over here and look at list children, I could snipe that off the list. So you can go through and try it, but I'm assuming you could do something where you
How about
have
we
read
recurse-
property but no list children.
So how about we recursively place invisible, what is it called? Invisible new folders under
Yeah.
every folder.
I mean, you could do that. You could probably hide in like alternate data streams or something and set an SEL over it. Like, yeah. A lot of people have not even researched how much to abuse this. There's like only a couple of cases. Like the invisible service is like the most infamous one of them. Okay, so before I keep going, does anyone have any questions on STDLs or processes or tokens or anything like that? Oh, yeah, it doesn't affect the security systems. The idea is this is a really complicated STDL that says you can't list this. So when I say list all the services on the machine, it'll skip it, right? And then if I were to know it's called rootkit and do ls rootkit, it would say access denied instead of not found to give you away, right? But if I'm actually saying list me everything on the machine, it won't come up. So if you suspected someone like me had a service called rootkit, you would need to go try to overwrite the SCDL of the rootkit service to be something normal. So then you could read it, right? So you would need to know the name to do that. So if you just name it a bunch of junk, then you're never going to be able to find it, which is the idea. Correct. Correct. Yeah. Okay. So this is something I want to talk about again with transitivity and threat modeling. And I mentioned it a little earlier than I meant to. But Windows has this concept of a security boundary, right? Which is, hey, if you cross this point, that constitutes privilege escalation. So under Windows, admin to system is not a security boundary. System to kernel is not a security boundary. Admin to kernel, also not a security boundary. But going from user to admin is a security boundary. And going from user to kernel is a security boundary, right? But what's problematic about this is that if you follow it transitively, you can end up not crossing security boundaries and then take enough steps that the change you did would count as crossing a security boundary. And because this is a flaw in the design of the system, it's not an implementation level thing, you can issue a patch, it's a flaw in the design of the system, there is no fix for this. And this has been around for a very, very long time. So there becomes this problem where for a normal person's Windows computer, you're going to be running as unprivileged local admin. So local admin in medium process integrity. Like value at RC on your computer, that's what I'd be running as. And I can hop from that to high integrity admin. Cool, that's not a problem. I can hop from high integrity admin to system. Okay, and now I can hop from system into your kernel. And now I basically made a jump from an unprivileged user that's just ran some random piece of code on your computer, and now I own your kernel. That is a terrible, terrible, terrible flaw. Because guess where all the detection mechanisms run? They run in your kernel. So you can have the fanciest CrowdStrike, Falcon, whatever, sending whatever logs. And if I can hop in and exploit your kernel without using an exploit, right, just following the features of the system, I can just own everything on your machine. I can have persistence, and I can turn off all of your security systems. And that's just Windows by default, right? So all you need, like your recipe for success to go destroy everything is you need one UAC bypass. You can pull off of GitHub and change like 2 characters. You can find a driver exploit by Googling vulnerable driver exploit, and then, modify that, and you have destroyed the entire Windows security model in like a week of effort. And this is like the full chain of how that would work. Medium integrity, UAC bypass, cool, I'm high integrity. High integrity, I can create a service, go to system. Now that I'm system, I can find a legitimate driver that's signed by a company with a bug in it. So an old one with WinIO, which was this awful driver from like 2003 that you're still allowed to run. It's business critical now because people use it in their products, that has an arbitrary kernel rewrite button. Cool. So I can go to the thing that says, don't let Ronan run his custom drivers with a setting, and I can use my arbitrary rewrite to write, let Ronan run his custom drivers. And then I run my custom drivers and I patch it to hide my tracks. Well, am I going to get detected? No, because my custom driver turns off your antivirus. So, Yes, yes, it was a feature. It was designed to like let you poke around in your system, right? Which is now I'm poking around in your system. But yeah, so this is why design level problems like are really pernicious, because this is something you could have done 10 years ago, probably 15 years ago. I don't know why people aren't doing it. They just haven't like sat down and like modeled the whole Windows kernel, but like I've done this before. I've done this multiple times before. It's something you can just go do with a little bit of dev work. Yes, it works on the latest Windows 11 with every security mitigation enabled. Plus CrowdStrike Falcon, Microsoft Defender for endpoints, Splunk, Sysmon, and FileVees. Yes. So you can go race through all of that.
Or they want drivers to be like start. They want people to start running drivers that run privileged environments, because I think like
Yeah. So it's complicated because the new move is they just assume the kernel is shot. And the whole Windows 11 security innovation is to say, cool, the kernel's shot. We're going to drop you into a hypervisor when you load. Your Windows kernel's in a VM, and we're going to put all your really secret stuff in a separate VM. And we're only going to let them talk via RPC. And that's how they've gotten around it. So this is then I'm going to go over probably in like 15 minutes, right? Where they have successfully locked down a lot of the secrets of the system across the hypervisor. But yeah, their approach has basically been, well, you can't really fix this, right? This is the original design specifications. We need to take the whole kernel and drop it in an untrusted environment, and then put the secret stuff in a different environment, and then watch how they talk. And that's a very successful security mitigation. Oh, okay. Yep. Yeah, because the issue is they have this big block list of like drivers you are not allowed to run that are supposed to get flagged by antivirus. But there are a couple of them, because I think I enumerated the entire list. I found 5 of them that were not blocked, and I looked them up, and all of them were using real products, right? Because they needed it to keep running. But yeah, I actually haven't looked into like what their guidance is moving forward to try to like cut down on that. All right. So that was like the most technical. Yes, up.
Suppose over here you said we can just disable the heavy VR.
Yes.
Once you're there, does that leave any trace on the system?
Ooh, that's a very good question. So yeah, think about how a distributed system works, right? It'll pull back and it'll report the changes on disk. So you have a race condition here where they'll usually send it every 5 minutes. They'll say, hey, here's all the things that happen on the system. So your detector is running in real time. The remote security analyst will get it every 5 minutes, right? So I can get in, and if I go in and kill the process, it's not going to get sent, right? If I go in and I patch the process and I say, hey, don't like actually have the ability to read the file system, right? They're like adjusting its token, I try to be stealthy about it. It will still have the cache of the last set of events it'll send over. So it depends on how you go about it. If you just sort of kill the process, there will be traces, I think, on disk. I don't know where it's stored, of like the diff of like, here's the events that get reported, right? You need to go in and clean that up. So what I did, which was a little bit like, not fancy, is I would go through, I would suspend every single thread in the process. I would sandbox its token so it can't talk to the OS. And then I would, instead of cleaning up the logs, I would just go and insert a kernel rootkit at the network stack. So it's under the firewall. So I'm not adding firewall rules. I hook the network stack and it's like, hey, don't talk to CrowdStrike.com, right? At like the network stack level. And that was like my hacky approach. The correct way, which I think you're getting at, would be to go through and clean that log. But I didn't have time to go research putting that together. So yeah, we'll leave traces. Okay, cool. So this is much simpler stuff, but it is kind of annoying. So unless you're running WSL, you're not going to have Bash or Zeesh or whatever on your Windows computer. You have command prompt, which is cmd.exe, and it's quite old. And then you have PowerShell. PowerShell is really cool. The syntax is quite different to a normal like Linux user, right? Because you have these like long verb noun syntax, like get dash history, right? But PowerShell is a very cool shell because it lets you use the .NET one time. So when you get into a computer, usually you're going to need to go stage some kind of like malware into it or whatever. But if you just want to run around looking at a reverse shell, you could use either command or PowerShell. And PowerShell for a long time was like the dominant way of controlling Windows computers, right? And what happened is people went through, because this was so rampant around 2014, they inserted logging features into how PowerShell was run. So now there's an antivirus in PowerShell. There's a whole logging system built into PowerShell. There's like a shell restriction, which is kind of like a jail that'll get put on PowerShell. And to break out of that, you need to mess with like compiler stuff with done at runtime to get out of that jail. And then they'll have the default execution policy, right? So they basically put defense in depth and put it into the shell, which is, again, weird, right? You don't see that in Linux. It's like a Windows-ism that they're doing. And the whole reason that they put all these features in is in PowerShell, I can run whatever C# programs I want, because it can run them fully in memory, reflectively. So I can run one command, right? With this thing in the middle here. And I can take any C# program and pull it into memory and go run it in PowerShell. And this is a really crazy property, actually, because it's never touching disk. You're not scanning it with an antivirus. You have a get out of jail free card where you can run whatever programs you want just using the Windows shell, which is why they went back in and added all of these features. There's also some other like fun reflective properties with it. You know how you can like curl and pipe sh, right? That's a very common thing folks are doing to stage bad guy stuff on computers that are like Windows computers running PowerShell, right? And so it would store like bad guy scripts on their computer, and so having to go drop that onto the disk and // it, you would just invoke web request, which is IWR, pull that down and run it straight into memory. And about 10 years ago, before antivirus EDR got to where it is now, and there weren't these logging tools, staying in memory would just defeat all of the detection mechanisms. So there were all these really cool tools on GitHub, like there's PowerUp, there's PowerView, right? A lot of them start with Power, and they let you do something really cool. So PowerUp would be like, I want to escalate my privileges, and it would run through all these checks, and then it would be like, oh, would you like to escalate your privileges that way? But find something, run this command and copy and paste it in. So it's this really cool, like script kiddie sort of meta where you could just auto check everything, bypass all the security systems and do that, right? And that doesn't exist anymore. So some of that has migrated to C#, which is why it starts with sharp, right? People have rewritten it in C# to go use it. Other like tools sort of died off, but it's interesting to me, at least, there's this whole era of like attacker techniques that came just from this specific shell. So I'm not aware of anything like that for like Bash, for example. So yeah, these days we're trying to be stealthy. PowerShell is a very poor choice because everything is looking at PowerShell just because of this history. So this sort of died off in around 2019, 2020, I'd say. But it's still worth knowing about, especially because we have done competitions, I believe Cyberforce last year, where they set up all the boxes using PowerShell and doing some of these things. And they didn't clear out the command logs. So I could go through and see everything they put on the box by just reading the shell history, right? So yeah, these are still worth looking at. Just maybe not so much like using as an attacker. Cool. All right, so anyone have any question on like the Windows shells? I didn't go over CMD because CMD is much more similar to a normal like Linux shell. The main difference is the command's different, like your ls becomes dir, and then you have to use backslashes for your file system. Whereas PowerShell has aliases in it. So you can use a lot of the bash commands. You can ls, you can ps, you can do whatever, and it'll go handle that for you. Nothing? All right, cool. So yeah, the other thing is there are a bunch of services running by default on Windows. So by services, I mean something a little different than what I mean in the network security context where it's remotely accessible. I just mean things that will run on boot as system or in the kernel like a driver, doing something important. And there's like a bajillion of these, right? Including if you have like a Windows for Business thing about like Xbox Live services built in. There's hundreds of them. Of course, just like Linux, if there's ever an issue with the access control to these services, that's an easy way to go escalate your privileges. Because there's already this thing that's running automatically as systems. If you can write into it, you can just put your bad guy code in there and wait for them to reboot. And then you now have like full privileges. So this is a very similar like sort of philosophy to all of the services on Linux. The only difference is SNB, which is on by default. And that lets you log in and put and get files and then start services. So a service technically is going to be any entity that you register with the OS to go run something as system in the background. So yeah, there are a bunch of these. So I'll try to get into the practical stuff. It's already 7:40, so hopefully I'll be able to get through this in time. The main thing is, if you remember, like way back to the beginning, I said, you know, you have a set of these tokens and you give processes a subset of those. So if you're a normal user and you're in medium integrity, you're gonna have none of these. But what if we're a little more granular? And we are not a local administrator, but we need one of these to go run a certain program. Like a lot of the IIS web servers, for example, have SE impersonate privilege. They can go like delegate or talk to other things, right? So if you're on the IIS account, normally for like a Windows server, you are not in that local admin group. You can't use that UAC bypass trick I talked about. You need something else. But if you have SE impersonate privilege and you think every privilege lets me go skip a check in the kernel, and you can look up a list of these, there's like a finite number of them that you can escalate your privileges with. Well, that's a case where you can actually just become someone else. So it doesn't matter if you're in the admin group. You can use some trickery with how Windows handles its authentication stack and become system just right off the bat, right? So some of these are pretty normal to go use. SE debug privilege is probably the most dangerous privilege you can have because this lets you arbitrarily read and write into other processes. What's the check we're skipping? Well, the check we're skipping is, do I have that access control over a given process or thread object, right? So that's an example. And if you just look up like Windows token-based privilege escalation, you can get a list of how to exploit all of these. So there's a command you can run, whoami/all. When you get code execution, it'll say, okay, like which one of these do I have? And if you see anything from this list, right, like, you know, you're gonna have a very easy time taking over that machine. The other thing, and similar to Linux I mentioned, is, you know, you could have a weak ACL over a service. And the other thing Windows will do, because Windows, you know, it's your friend, it's very convenient, will go break down the spaces in your file paths. So let's say I have a service that's looking for C, program files, test service.exe. But it's not there. You know, I deleted it, I moved it, whatever, and I started. Well, it'll actually search first for C program.exe to break the space. And say, all right, it's not there. Let's break the next space. C program files test.exe. Not there. Let's go break the next space. C program files test service test.exe, and then to look for test service. So if your permissions aren't locked down, and you can write a file in there, then you can take over the service. Now, what's interesting is seeing this for an exe in the real world is fairly rare. What's much less rare, if I skip over here, is seeing it for a DLL. Does anyone here know what a DLL is? Okay, cool. Can somebody explain it to me? Just shout it out.
It's basically like, it's almost like there are some methods that exe applications can use to, they can just call those methods and query it.
Exactly, yeah. And the DLL will live somewhere on disk and it'll get loaded up, right? So what happens, this one doesn't have any spaces, but it's susceptible to the same search order thing if it did. If we're trying to load and call a DLL that doesn't exist. Well, the idea is this is very common for a lot of applications that need stuff for debugging or compatibility features, and it's not always present. So you can just go look, you can either reverse engineer it, or you can think on event viewer, which will look for calls to this API for load library and say, hey, you know, is there something here that we can't find, and can I write to it? And if anyone more privileged than you is doing this, then you have a very easy way of taking it over by just saying, well, put the compatibility library there and let it get loaded, and then we'll just put malware in it, right? And they run their thing, we take it over. So this is like a sort of variation on that theme of, hey, maybe it's not directly a weak ACL, there's a weak ACL on one of the dependencies, and we can use that to take over the process. So you can do, these are also, they follow the same search order. So if you can do any of the search order hijacking tricks, you can do that. And this happens all the time in real products, right? So infamous one I used like fairly recently is PowerPoint needs a library called msoarea.dll. And it'll look for it by default for that DLL search order in the current executing directory before it falls back to breaking up spaces. So let's say I want to run bad guy stuff in legitimate PowerPoint, like I'm phishing someone, right? Well, I can give you the real PowerPoint. That's okay. I'll give you a legitimate PowerPoint executable, and then I'll go drop a hidden file in there in that directory called msoarea.dll, put my malware in that instead. And then you go run it, it lists your processes. Well, say okay, right? It's PowerPoint, but inside of that PowerPoint, it's been infected because you have basically, taken over a core dependency of that program and put something bad in it. This is a very, very common vulnerability class to go find, right? Because as an attacker, you can go find these in like 10 minutes by just looking through the output of the system calls and saying who's trying to load a library and failing to find it and can I write to it. And there are filters that you can do to just drop an app in and run this and automatically see is it vulnerable to this. So this is like the easiest way to get a local CVE ever, assuming it's running something more privileged. Okay, yeah, UAC bypasses. So UAC bypasses, what I was going over before, we bypass that check of the would you like to elevate from a medium to a high integrity process. So how do these work? Why do these exist? Well, these are basically the same thing as a set user ID bit on Linux, right? So imagine if I were running password, which will set user ID to root, right? If there was some escape in there that would let me go run shell commands. So we talked about this in the Linux privilege escalation meeting. Well, the cool thing about Windows is it doesn't patch those. So there are escapes, for example, in terms of like DLL hijacking, right? For some of the core processes of auto elevate, where it's like I can put a DLL in there and then go say, hey, go run this legitimate program as high integrity, right? It'll auto elevate to that, and then it'll go load that malicious DLL, and now we've hopped to having high integrity code execution. There's a bunch of them, right? There's, for example, certain programs on Windows that will run arbitrary shell commands if you write to the registry key that it accesses. So there are many of these. I think the classic one was there's like fodhelper.exe, which will auto elevate to admin. And that lists out like your language and locale settings, I think. So this would be a very common thing like, for crimeware, where you've been infected and then you see this thing pops up. It's like, well, why is my settings popping up? Well, a lot of times it's actually, in like cybercrime context, it's a fairly unsophisticated attacker. They're spawning this GUI to go elevate to admin and then get persistence on your computer. And there's actually a setting for this called always install elevated. And this is a very similar thing where it'll run any installer file as high integrity admin as well. So this is turned off, but it's very common to see this turned on because it makes installation like really easy in terms of just like, not telling someone like, did you remember to right click run as administrator if you're in like, an organization. So some of these will spawn GUI applications, some of them won't. But if you just Google like UAC bypass GitHub, right, you can find a ton of these. And they all work based off of this idea of auto elevation. So yeah. So if you hop on a Windows box, right, a lot of times what you're looking to do, actually like these specific tricks, is the exact same stuff you'd be looking for Linux privilege escalation of like, okay, can I take over something I shouldn't? Am I part of something I shouldn't be in? So you do command/all, and then it'll list you out all your privileges. You can do net user, which is like cat etc passwords, like who's on the box, net group, what groups are on the box. System info is good to see your current version. You are almost never going to be, running kernel exploits because Windows will auto update. So you're not going to see that really. IP config is just nice to see what networks you're a part of. ARP-A is nice. They'll tell you who your computer has been talking to. Netstat-ANO is like, hey, what are all my listening ports on the computer? Which is a nice way to go find, am I running like some kind of server or service or something bound to localhost? You can just look in the program files to go see what software is installed. Maybe one of them is known to have like a DLL hijack vulnerability or something like that. Same thing for looking at downloads. sc.exe query is going to list out all the services on your computer. So those are things that are running a system on startup. And then you can use the PowerShell commands to look for like, common user files, right? So yeah, that's all well and good, but you can just automate it as well. Because there are a lot of folks that are hopping on Windows box and like very quickly being like, I want to go see what's unusual about this, right? So there are cool tools to this. There's SharpUp, which is like the old power up thing I talked about, where it'll help you automatically elevate your privileges. There's Seatbelt, which is just a checker, and it'll check for the most common things like, hey, always install elevated. Do I have any dangerous privileges in like my token? Can I, do a UAC bypass? And then if you want to check all of the things, kind of like we went over LinPeas, there's also a WinPeas. And WinPeas takes a while, but that will check everything. So I would recommend if you're going through doing like hack the box, right? Try to go through some of these commands and understand what they're doing, because one of the automated tools will have like thousands of things it's doing. So go through and try to understand the fundamentals. But when you're doing this for real, like 9 times out of 10, you're just be running an automated tool like this to go scan it. So that's the idea. The last thing I'm going to go over very, very quickly, because we are almost at time, I'm just going to go over like a high-level overview of this, is authentication. There is one other super gigantic design level flaw in Windows authentication. And in fact, there is a talk by the head of NSA's tailored access operations where he blamed this as like the vulnerability that is like destroying people's networks, right? Google Usenix Enigma talk Rob Joyce. Okay. So Windows has NTLM authentication. That's like NTLM is like the hashes they're using, right? So if you think your Etsy shadow on Linux will hash your password, this is what Windows uses for your local authentication. And they had this really clever idea in their heads that, well, what if we make it so we do a zero knowledge proof over the network by a challenge response? They're like, okay, cool. What are we going to use as our secret for this zero knowledge proof? And then some brilliant genius said, instead of using their password as a secret, let's use the hash of their password. So that we're going over a network, and want to prove that this is my identity, my secret material is the password hash. This is a terrible, terrible, terrible idea. The reason is if I hop on, I'll just give this example, right? A Linux box, and I say, list me all the hashes. Cool, here's your hashes. Well, I have to go try to crack those with a big GPU cluster and say, okay, this is it. Well, for Windows, if I hop in and I say, give me all the hashes, and now I can prove to everyone on the network, hey, that's me. All I need to do to compromise every single user identity on this box is to just read the hashes, and I can become them over the network. So if you have, let's say, a domain administrator who is like logged in on this box and you dump their hash, well, now I'm a domain administrator from the perspective of everyone on the network, including the domain controller. So this used to be, because there's been mitigations against this now, but they're not real ones. I'll go into that in a second. Where the use to like the old way you could fish your way to domain admin is you would get on some unprivileged box, right? And then you would phone up your target org's IT and be like, hey, IT guy who has the permission to remote into other people's boxes, I'm having a problem. Could you please log into my machine and help me out with this? They log in, you dump their hash, and now you can log into everyone else's machines because you have the ability to go remote in. This has since been stopped with Credential Guard. So like I said, the innovation of Windows 11 is, well, what if I take all of your credentials and all your hashes and I put them in a separate virtual machine because their whole kernel's shot and is unrecoverable, right? And now if you try to read through and get those secrets, Credential Guard will stop you and you cannot get those hashes anymore. But over the network, the pass the hash flaw is still there. And there are many other ways of abusing it. Sorry, what's up, Sujit?
Like, what is happening? Because this isn't some like, this is just a protocol. You can update it to communicate with, you know, specific processing style. This is a process where I change.
This is the authentication mechanism that all of Active Directory has been built on since 2003. So in order to go patch it, you need to come up with a new protocol for Active Directory and then rebuild everything like from scratch. So the main reason is back compat. So they've tried to just say, well, let's not use Until anymore. Let's use Kerberos. But because of back compat, even if you have all those boxes checked, you can still log in with NTLM with some trickery. So yeah, they've been trying to fix it for a long time in theory, but in order to get stuff actually working, it's never been properly fixed. I don't know. I don't know. I think Kerberos was doing it initially, like to try to prove it, and this I don't know if this was before or after.
So I can.
Yeah.
You don't know anything else about the user except for the one specific thing that you should want to know, which is in this case, are you authenticated user now? So you don't know the path. It's like if you give somebody not your actual password for login, but you give somebody like a way to check. Oh, this is the authenticated user without actually giving them any additional information. Which is usually what makes it really powerful is that you're not giving there's no because it's between two untrusted like devices, let's say you don't trust the person, but you still want access, to connect them. With the zero knowledge proof, you don't have to give them any other information, you can still accept it. That's what's like really powerful about it, why it's so useful.
Yeah, so I kind of skipped over it because of time. We have about 4 minutes left, but this is the idea of how it's supposed to work. It's a challenge response protocol. And the way we send our response is where we're going to send some kind of encrypted thing back where the key is derived from the password hash. So this is how you would verify somebody's identity using this NTLM authentication, like a very high level. But yeah, the problem is when you make the hash your secret, right? Well, now you don't ever need to crack a hash. If you obtain an NTLM hash that is equivalent power to the clear text password, which is a terrible vulnerability if you have the ability to go read hashes. So what they said is instead of fixing our network, let's just block them from reading hashes by dropping you into a virtual machine, right? And then putting your hashes in a different virtual machine and then having them talk via RPC. So even if you get into the kernel, you can't get any of the hashes. So the idea is to get past this, you would need a hypervisor 0-day to be able to go recover those hashes and continue with this exploit chain, of which there have been 0 on record. So before this, you would use a tool called Mimikatz. Hopefully some of you guys have heard of Mimikatz. This is like the most signatured piece of malware ever. So the idea is once you get system, you can just use some easy breezy commands and steal all the hashes, including of people on the domain, not just local users. So this is built into Meterpreter. You can use it with like the hash dump command or load kiwi and then do that. You can grab it off of GitHub. This does not work anymore because of Credential Guard. Credential Guard is not on in our cyber range. So when we get the Windows box stuff, you guys can still run through and go run these attacks. But in the most modern, latest and greatest up-to-date things, Credential Guard will be on and will be blocking you from taking these hashes. The other thing is in-packet secrets dump. This is a really cool one. This will grab everything that can on the device without actually running an agent. So it doesn't drop an exe. It just grabs as much as possible from the registry. So you can get like cache domain logons that you can crack and sometimes recover a password. It'll grab all of the local users in the box, but because it's not reading into that LSASS process memory, it can't attack things in the domain. So you can't get any new access really out of this unless they're like logged in some unique kind of way, which will sometimes happen, but it's not super common. Okay, so I know that was a lot. That was actually like the densest, I think, presentation we have ever done and hopefully will do. So that is like our whirlwind tour of the Windows OS. And the reason is you have to understand how the Windows OS is doing a security model to understand Active Directory. And Active Directory, you should get motivated if you want to be a hacker. 95% of the Fortune 500 runs Active Directory. Government runs Active Directory. So if you know how to hack this one piece of software, you can hack 95% of the organizations. And this is why it's been like the target from cybercrime to like nation state APT groups. Everyone is trying to get into Active Directory because most things that you can think of that are running any kind of valuable corporate or government system are using this one piece of technology. So, come to the Active Directory meetings, learn how to go hack it and change your grades, because that's what UIUC runs on. It's all Active Directory. So, yeah. I know that was a lot. I don't expect anyone to go memorize any of this stuff because it is a lot. But do you guys have any like closing questions before I like stop the recording and stuff? Sweet. Okay. So either you guys get it or you're totally overwhelmed by the Windows security model.
Before
awesome.
we put this video up onto YouTube, maybe you should clarify that what you said is a joke.
Well, yeah. If you were to go try that and you didn't have any kind of fancy malware, people would know exactly like, hey, we got some guy logging in doing this from Illinois Net with his net ID. Like, you're gonna get swatted. And if you're clever enough to go get around that, then you probably already have a job and have no need to be doing that. So, yeah.